A black hole with about 1 million times the mass of the Sun was just caught tearing apart a star 30,000 light-years from the center of its own galaxy. That is roughly the distance between Earth and the middle of the Milky Way. Only this black hole is nowhere near where astronomers expected to find one. Every supermassive black hole confirmed so far has been anchored at a galaxy's core. The assumed address for anything that massive. Astronomers at the University of Maryland caught this one only because it had a meal. In November 2025, an artificial intelligence program sifting through sky survey data flagged an unusual burst of ultraviolet light in a galaxy 750 million light-years away, outshining the entire galaxy around it for months. That flash was a tidal disruption event. A black hole shredding a star and radiating the wreckage. The result, published in the Astrophysical Journal Letters, is the first confirmed case of a dormant supermassive black hole caught this far from a galactic center. Here is how it was found, why the location matters more than the black hole itself, and what one detection can and cannot tell you about how common these wanderers really are. Consider how a black hole that emits no light of its own ever gets discovered at all. A dormant black hole, one not actively pulling in gas and dust, is invisible. No accretion disk, no glow, nothing for a telescope to catch. The only way to find one is to catch it in the act of doing something violent. That is what a tidal disruption event is. A star wanders close enough to a black hole's gravity that the pull stretches and shreds it, spaghettifying the star into a stream of gas that briefly radiates with the power of 10 billion suns. Researchers built an AI program specifically to scan the Zwicky Transient Facility's sky survey data for that exact light signature, launched it in August 2025, and had a candidate flagged within 3 months. NASA's Swift Observatory followed up to confirm the burst behaved like a genuine tidal disruption event rather than a supernova or some other flare. Only after confirming the event was real did the team locate exactly where in the host galaxy it happened, 30,000 light-years from the core. And that positioning is the actual discovery. Consider why the location is the headline and not the black hole's existence. Supermassive black holes, the million to billion solar mass giants distinct from the smaller stellar mass black holes left behind by dying stars, have only ever been confirmed sitting at the gravitational center of a galaxy, including the one in our own Milky Way. That is not a coincidence of where astronomers happened to look. It follows from how galaxies and their central black holes are thought to grow together over billions of years. Gas and stars funnel inward, and the black hole grows in lockstep at the bottom of that gravitational well. A supermassive black hole about 1 million times the Sun's mass, roughly the same mass class as the Milky Way's own central black hole, sitting 30,000 light-years out in the galactic suburbs does not fit that picture. It should either have fallen back toward the center over cosmic time, or never have formed out there in the first place. Finding one anyway means either the standard picture is incomplete, or this black hole has a specific, unusual history that put it exactly where it should not be. Consider the leading explanations, because astronomers already have 2 candidates. The first is galactic cannibalism. Large galaxies grow partly by merging with and absorbing smaller ones. And if a smaller galaxy carrying its own central black hole gets swallowed, that black hole can survive the merger as a leftover, drifting through the larger galaxy's outskirts long after the rest of its home galaxy has been torn apart and absorbed. The second is a gravitational slingshot. In a chaotic encounter between multiple massive objects, one black hole can get flung outward onto an eccentric orbit, The same physics that lets spacecraft use planetary flybys to gain speed. Just at a catastrophic scale. Both explanations predict that a Milky Way-sized galaxy should be quietly carrying a small population of these wandering black holes. Remnants of its own violent merger history. Most of them completely dark and undetectable unless one happens to catch a star. That prediction is decades old. This tidal disruption event is the first direct observational evidence that it is actually true, rather than just a reasonable guess from simulations. Here is what one detection does not prove. This is a sample size of 1. A single confirmed wandering black hole tells you the phenomenon is possible. It does not tell you how common these objects are, whether most galaxies carry several, or whether this particular galaxy is unusual. The 30,000 light-year distance is also a projected position, measured from the two-dimensional image, not a precise three-dimensional location. So the true distance from the galactic center carries real uncertainty. The discovery method has a built-in blind spot too. Astronomers only find wandering black holes when they happen to be shredding a star at the exact moment a survey is watching, which means every dormant wandering black hole not currently eating anything stays invisible by definition. That is a significant selection effect. The AI program deserves credit for flagging the candidate fast. But it did not identify the physics. It recognized a light pattern. Human astronomers and follow-up telescope observations did the actual confirming. Treat this as proof the phenomenon is real, not as evidence for how frequent it is. That number needs many more detections. Quick recap. A University of Maryland team used an AI-assisted sky survey to catch a supermassive black hole, about 1 million solar masses, tearing apart a star 30,000 light-years from the center of its host galaxy, 750 million light-years from Earth. The result, confirmed with NASA's Swift Observatory and published in the Astrophysical Journal Letters, is the first direct evidence of a dormant supermassive black hole living that far outside the galactic core. So, signal or noise? Signal. On the observation itself, this is a peer-reviewed, telescope-confirmed detection of something theorists predicted but nobody had directly caught before. And it is a genuine data point for how galaxies build their black hole populations through mergers and gravitational slingshots. Noise. On any headline implying wandering black holes are suddenly known to be common or that your galaxy is full of hidden ones. This is one confirmed case built on a method that can only see them when they are actively eating. Watch for how many more of these the same AI survey catches over the next few years. That count is what turns one strange detection into a real population estimate. Subscribe for space stories checked against the actual paper, not the headline. Signal from the noise. Every week.